Hello guys, it's been a long time since I've made a video, so I thought of making a video on vectors, solving some iGCSE and GCSE questions. Uh, so I thought of doing this so that gives you an insight on how to approach GCSE questions related to vectors so that you can easily solve them. There are three questions that I'm going to be solving, so if you guys enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. Otherwise, let's get straight to it, alright? Okay, so the first question is given OA is equal to A, OC is equal to C, AB is to C. P is the point on AB, such that AP to PB is 3:1. Q is the point on AC, such that OQP is a straight line. Use a vector method to find AQ to QC. So, first rule when solving any questions is to just keep it simple. Remember, just keep it simple, keep all the methods straightforward. So we have to show something. So the first clue it's given is OQP is a straight line. So that means you know that this is going to be a straight line. That's somewhere around that point there. And you also know you're given the parts of AP to PB. All right. I'm just going to write small here because there's not much space. So let's just write that down. So AP to PB and 3:1, right? So your first thing that you're going to do is find out the total parts. So the total is 3 plus 1, that is going to be 4. The total parts is 4. Okay, so we have to find out what AC is. If we know, we have to find out actually what AP is, and we know what AB is, so that clue is given that AB is 2C. So given from the question, it's straightforward. Okay, so now in order to find out what AP and PB is individually, we know the vector of AP, okay, given in vector form. AP is 3/4 of AB. It's 3/4 of AB, which means that 3/4 of AB, which is 2C, that will make it 3/2C. So AP is 3/2 of C. Now PB, on the other case, is quarter of AB. Since the total parts are 4 and AB is given 2C, it's given from the question. So quarter of 2C, that will make it half C. So we have found out what AP is. So we're just going to write that down to 3/2C. We found out what PB is, half C. Now that's straightforward, so we're going to keep it simple. What we're going to do next is we're going to find out what AC is. So looking at the triangle, if you look at this triangle here, AC is the forward direction, so you're going to go forward. So you're going to go from AO to OC. Now in order to do that, right, you're just going to write AC vector is we're going to move from AO, if you look at the diagram, and then move on to OC. So AO is A, but since we're going in the reverse direction, we're just going to do minus A plus C. So AC is equal to minus A plus C. That's it. So you have found out what AC is. Your next question, your next your next clue that you're going to find out is what AQ is. So AQ is this direction. So we know that AQ, since we have to find out the proportion of AQ to QC, we know that AQ is some scale factor of AC. Some scale factor of AC. Since we know what AC is, it's going to be K brackets A plus C, which is going to be equal to minus KA plus KC. So you have to know, we're just opening the brackets, so you have to, your algebraic brackets should be really strong, opening the brackets, alright? The next thing that we should do is to find out what OQ is. So now in order to find out OQ, that's this direction here, we found out what AO is, and we know what AO is, and we know what AQ is now. So to find out what OQ is, okay, we're just going to find out what OA is, and we're just going to add that up with AQ. So we know that OA is A, since it's going the forward direction, plus AQ, that is minus KA plus KC. Since they both have AA, we're going to group these like terms together to get is equal to A brackets 1 minus k plus kc. So your factorization in brackets should be really strong. So now we have found out what OQ is. Now the next step is to find out what, let's see, since we know what OQ is, we need to find out what OP is. So in order to find out what OP is, you look at the direction again. We know what OA is and we know what AP is, right? So what you're going to do is to find OP, you're going to go from OA to AP. So that's going to be OA, in this case, is A, that's the direction, plus AP, 3 by 2 of C. Okay, now we know what that value is. Now what we're going to do is an important step. Since we know that this is really important, I'm just going to write down what OQ is. From what we found is A brackets 1 minus K plus KC, and we know what OP is, right? We know that OP is A plus 3 by 2C. We're going to, since the OQ and OP, since they're proportionate with each other, right, we know that A brackets 1 minus K should be equal to this value here, right, of this value that is of 1. So since that, we can find out what A is. Indirectly, we know that A is equal to 1 brackets, since A is times multiplied by something, we know that they're proportionate to each other. A times something is equal to 1. So we have 1 minus K. So now we have found out the value of A. Now same thing, you're going to do this with KC and 3 by 2 KC because they're proportionate to each other. OQ is proportionate to OP, right? So we know that KC is equal to 3 by 2. That's 3 by 2 of the value, and C should be, let's keep 3 by 2 as 1.5 divided by K, okay, just to keep it simpler, so that you guys know how to do this. So in your calculator, if you put 3 by 2, you should be getting 1.5. Alright, let's keep it simple. We have found what A is, we have found what C is, all nice and ready. Alright. Now your next job, your next thing that we need to do is just equate both of these equations and cross multiply them. Once you cross multiply them, you should be getting K's value of 0.6. Okay, hopefully you guys should know how to do algebraic multiplication, so in that way we should be getting K is equal to 0.6. Now this is a crucial step that you need to know, is that we have to find out what AQ to QC is. So we have to find out what AQ is. Since we know what AQ is, we have to find out what AC is. So that means we have to add this up with QC. Now, since we know something that AC, let's just find what AQ is first. We know, we found out what AQ is. We know that AQ, right, is K of AC, right? AQ is K, some factor of AC. That's from this place. So we know indirectly that K is 3 by 5. Since the reason is because, why is K 3 by 5? Is because we know it's 0.6 of AC. So that gives a hint that if you put 0.6 in the calculator, 0.6 is equal to 3 by 5. It's just a fractional form. So it's 3 by 5th of AC. That's what we found right here, K. Alright? So 3 by 5th of AC, that gives a hint and that we can find out. So we know that AC is equal to, that's here, we know that AC on the diagram, we know that AC is equal to AQ plus QC. So they both add up together. We know that AQ plus QC. Okay, so now we have to find out, we know what AC is now, we know what AQ is. We just need to find out what QC is. In order to find out what QC is, you just do a vector of AC minus a vector of AQ. So you have AC, which is a QC, in this case, to find out what QC is, we know what AC is, right? So AC is 3 by 5th. If you look there, that is minus A plus some minus. So once you find out what AC is, you should be getting 1 minus AQ, that is 3/5, right, is equal to 0.4 of the fraction of AC. Alright, so now we know, we found out that that is 0.4. We're just going to equate 0.6 to 0.4. This is going to be done in terms of, see, we're not 1 minus 3/5 is not the assumption of AC and AQ. It's just that since we know what let's say what AQ is, we know that AQ is 3/5 of AC. We know that the total line must add up to something about 1, so we just do 1 subtract 1 to get the other portion of it, to get 0.4. So we're just going to equate this into 3:5, and 0.4 in terms of fractional form, remember, just put in calculator, you get 2:5. Now how do we make this whole numbers? Now in order to make these guys whole numbers, what we're going to do is we're just going to multiply all of them by 5. This should be giving us the values of 3:2. That is your answer in terms of fractional form. You would have a column, I think there will be a row, AQ is to QC. You just put 3:2. This is your final answer that you must write. This is critical that you should write 3:2, make them into whole numbers. Okay, so this is as straightforward as it goes. It just, you have to just understand the relationship of how the proportions work. Okay, let's move on to the next question. The next question, keep it simple, okay guys? Next question is ABCDEF is a regular hexagon. ABX and DCX are straight lines. AB is equal to A and BC is equal to B. Now find EX in terms of A and B. Give your answer in its simplest form. Alright, so we can see that this is a regular hexagon, so that should immediately give you the answer of an assumption of what are the interior angles, right? So we know that the interior angles of a hexagon is equal to 180 minus 360 degrees divided by n. So that's 180 minus 360 divided by 6 sides of the regular hexagon. So we know that's 360 divided by 6. That should give you 120 degrees per interior angle of this regular hexagon. So that's 120 degrees per hexagon. Alright, so that's 120 degrees. Alright, I'm just writing this all down. Your next clue should state that since ABX lies on a straight line, they are a straight line, it's clearly stated there. So ABX and DCX are straight lines. We can find out what the angle of XBC is. So XBC is going to be 180 minus 120. The reason is because the angles on a straight line, they add up to 180 degrees. So that means that XBC is 60 degrees. That's pretty important that you understand how that thing works. So XBC is 60 degrees. Since the same concept applies, we know that XCB is also 60 degrees, since this line adds up to 120 as well. So looking at this, you can make an assumption that this shows you an equilateral triangle. So you're just going to highlight that to show the examiner that you know that this is an equilateral triangle. Since this is an equilateral triangle, we know, just to confirm it, you can just do 180 minus 60 plus 60. This should be as well as 60. The whole aim now is to find out what EX is. So EX is just a straight line, right? EX is just a straight line here, E and X, okay? These are 2 points that you have to find out in terms of A and B. So we know that AB, okay, once we have found out all the angles, we know that AB is equal to A, so that's the forward direction of A, and we know that BC is, from this direction, we know that BC, okay, I'm just going to clarify that so you guys can see it clearly, we know that BC is B. The reason why I found the angles was to make sure that triangle XBC is an equilateral triangle, and to make sure that the regular hexagon has all its angles. So we just calculate the interior angle of the hexagon in order to find out if the angles in the triangle XBC is an equilateral triangle having all angles of equivalency to 60 degrees. Okay, so since we know that, your next step is now since we know that AB is equal to BX because they are in a straight line, and since we know that XBC is an equilateral triangle, they must be equal to each other, right? So they must be equal to A. So that makes BX A as well. Okay, that's a good start. And now your next start is to find out what XC is. So looking at the triangle, and I'm going to draw the triangle, keep it simple, okay? So it's going to be BX and C. We know what BX is now. BX is A, since if they lie on a straight line, they must be equal to each other because they're on a straight line and equilateral triangle, same sides, so it's alright. We know that BX is A, and we know what BC is. It's C. How do you find XC? XC, this is basic vectors. XC notation is to find out the XC vector. Okay, what you're going to do is you're going to do XC, that's this arrow here. In order to find out what XC is, you're going to go from XB, vector A, XB, plus vector BC. Okay, so XB, that is minus A, since it goes in the reverse direction, you can add it with BC. This is B, okay, plus B. So that would give you XC is equal to minus A plus B, and this is the same thing as B minus A. Okay, we're just going to create it there as well, so B minus A. Since you have found out what XC is, alright, you should know that EX, right? To find out what EX is, you have to find out EX. You're going to move from ED to DC and to CX in order to get the vector EX. So you're going to move from ED to DC to CX, alright? Just reload this thing so it's more faster while solving. So you're going to move from ED to DC to CX. Now, how do I know what the value of ED? ED is equal to AB, so they both are equivalent to each other. Since this is reason is because this is a regular hexagon, so the sides must all be in proportion to each other since their angles are all equal. So we know that ED, we can just write it down there, ED is equal to AB, and that's going to be equal to A. So we know that ED is A, since ED, because of that reason, we're going to say that ED is A. Now, DC, what's the story for DC? The DC part is, since we know that XC, right, we found out what XC is, that's this direction here, is to be B minus A, we can say that CD is equivalent as well. This is because DCX are straight lines. They must be equal to each other, right? So we know, we can say that CD is equal to B minus A. And DC is just the reverse of this. So you're just going to put a negative value of minus BA. Okay, so we found out what DC is. We know what ED is. Now, what is CX? CX is just the opposite of what XC is. That's literally, that's it. So CX. So we know that CX, right? So we're just going to separate these two together so we can see that CX is just equivalent to the opposite of B minus A. Now we can find out what EX is. We're just going to do EX is equal to ED, that is A, minus, the reason is because it's DC, B minus A. They add up, since they add up it just becomes negative, minus, what we're going to do, actually, we're going to write the steps here so that you can clearly see the idea behind it. Okay, actually, yeah, we're going to say that EX is equal to A minus, this is connected with this part, okay? I'm just going to draw a nice arrow there so you can show the connection. So A minus B minus A, alright, because the reason is because this is DC and it's minus B minus A. It's just like when you add 2 plus minus 2, they end up subtracting each other, so 2 minus 2. So using that same analogy, we're just solving this question, okay? And then we're going to find out what CX is, and we have already found what CX is, and that's going to be, let's just erase this part, so that's going to be minus B minus A. Now what you're going to do, I'm just going to open the brackets all up, so you're going to get something like this. This is simple algebra, so you know you guys can do it as well. minus b minus b. So 3a's, that is 3a minus 2b minus b minus b, that's minus a minus I. Sorry, minus 1 minus 1, that's minus 2b. So that is ex is equivalent to 3a minus 2b. This is your answer for good 4 marks. This is the question that you guys must know how to solve, okay? That's awesome. Alright, let's move on to the next question. The next question talks about OAB is a triangle, OA is equal to A, OB is equal to B, and C is the midpoint of OA, D is a point on AB such that AD to DB in terms of ratio form is 3:1, whereas E is the point such that OB is equivalent to 2BE. Using a vector method, prove that the points C, D, and E lie on the same straight line. This is for 5 marks, so you have to score this point. So now, in order to do this, you have to, let's look at the triangle form. We're just going to draw the triangle. So I'm just going to draw a simple triangle there, and I'm just going to call it O, A, and B. Okay, O, A, and B. And since we know that D is a point on AB, so we know that D is a point on AB, I'm just going to call this D. Alright, and we know that C is the midpoint of OA. We know that C is the midpoint of OA, so that gives us ideas. Okay, so we know that this is D, we know that this is C. C is the midpoint. This is just a rough idea of where C might lie, okay? And we know that E is a point such that OB is equal to 2BE. So that means C, D, and E lie on the same straight line. So that we know that this point E is going to be somewhere here. So what you're going to do is you're going to remove this. I'm just going to draw a nice straight line and just going to call this point D. So can you guys see that? That C, D, E, they lie on the same straight line. So we're following the rules of this idea. So since C is a midpoint, they've stated that C is a midpoint, OC must definitely be equal to CA. Okay? And what all clues have they given? They have given that OA is equal to A, so going in the forward direction. We know that OB is B. Alright, so now what we need to do is find out what AB is. Keep it simple, okay? So AB is AO, vector AO plus OB. So AO, since it goes in the reverse direction, is going to be minus A. That's minus A. Since we know that OA is equal to A, we know that AO is going to be minus A. We're going in the reverse direction. Plus OB, that is B, we're going in the forward direction. And that's how we find out the vector of AB. Okay, let's find out what AD is. Now, in order to find out what AD is, we have to look at the parts. So the total parts, that is going to be 3 plus 1, and that's going to be 4. We know that AD has to be a fraction of something, right? So AD is 3/4 of AB, since the AD lies on AB. So we know by looking at this, we're going to just write down AD vector is going to be 3/4 times AB vector, and this is going to be 3/4 of minus A plus B in brackets. Now when you expand this, okay, when you expand this, you should be getting 3/4 minus 3/4. Just going to write that down more clearly so you guys can see it. So opening up the brackets, you get minus 3/4 A plus 3/4 B. We found out what AD is. Now we have to find out what CD is, okay? Since we have to prove that CD and E lie on the same point. So we have to find out what CD is, the vector CD. Now, how we're going to find out CD is we're going to use this triangle. Can you see this triangle ACD? And we know that CA must definitely be half of something. So we know that CA is half of the vector OA. So we know that CA is half of A, since it's a positive direction in the front. So we know what CA is now. Once we know what CA is, in order to find out what CD, you're just going to go from CA to AD. That's it. Okay, we found out what CA is, it's half A. We found out what AD is, and you're gonna add, okay, you're gonna add brackets minus 3 4 A plus 3 by 4th of B. Opening this brackets up, you should be getting CD's value to be about, you guys should know how to expand the brackets, it's critical. So it should be quarter A plus 3 by B of 4, okay, 3 by 4th of B. Your next step is to find out what CE is now. Okay, now in order to find out what CE is, you need to go in one direction. You need to go from CO to OB, then to BE. Alright, so we know that OB is equal to twice of BE. That gives you an assumption that we have to go from CO to OB, and then we're going to add it up to BE. Alright, so we're going to use this triangle here, and we're going to go in that opposite direction there, and then go in the straight direction. Alright, so CO, remember, like I said, OC must definitely be half of A, half of OA, again as CA. There, it's because C is a midpoint, so OC is equivalent to CA. Alright, and CO is just the opposite of minus half A. Since it goes in the reverse direction, we know what OB is. OB is B. It's given in the example above, in the question, OB is equal to B. So you're going to just add B. And now, what you're going to do is we're going to go for BE. Now, since we know that OB is equal to B, and BE is twice of OB, we can technically find out what BE is. So BE should be equivalent. So it's like saying that this is 2BE, right? It's going to be equivalent to OB, alright? And we know that 2BE is just algebraic, right? OB is B. We know that BE should be the half of B. So this individual portion just tells you that it's half of B. So we can just put it there, BE is equal to half of B. And we just add it up there. Now we can find out what CE is. Once you solve this algebraic question, this algebraic equation, you should be getting about minus half A plus 3 by 2B. Now, can you guys see some comparison here? Is that if you look, let's take CD. Okay, we're just gonna write down what CD is. Minus quarter A plus 3 by B of 4, and we know that CE is equal to minus half of A plus 3 by 2B. Can you guys see any comparison here? We can clearly see that CE is twice, right? CE is twice of CD. So the reason is because if you look at this, quarter times 2, because CE should be twice, I'm just going to write it down that CE is twice of CD. The reason is because if you look at quarter in CD, quarter times 2 is equivalent to 2 by 4, which simplifies to half. And that is equivalent to what CE stands for, right? So that gives you a clear picture that CE is equal to twice of CD. Okay, so you're just going to write that CE is twice CD. That's it. So CDE is a straight line. Alright, I think that's it, right? So we know that CE is equal to 2 CD times 2 times the vector CD. This gives the assumption that CDE is a straight line. So CDE is a straight line. So this is so simple, guys. You can score easily 5 marks just by understanding this. Just keep it simple. Just understand the question. You guys can do it. Otherwise, hopefully this should have been a short video so that taught you the 3 ways, not the 3 ways, like how to approach questions related to vectors and make it easy for you guys to understand. Hopefully, good luck to all those who are doing the math exam that's coming up. Otherwise, if you guys enjoyed the video, please do like, share, and subscribe. It really helps the channel a lot. And do share it with your friends or family. Otherwise, just like the video. Just relax, enjoy, and study hard. All right. A new video will be posted soon, so let's see about that. All right. Bye, guys.